My name is Mohit Kumar. I am from batch AI 0725. The name of my instructor is Saurav Kapil sir. In this video, I am discussing about my major project. The name of my major project is Decision TreesThis project. In the top section, I have provided the goal of my project. The goal of my project is to detect whether a loan applicant is high risk or low risk on the basis of previous data. I have uh, give the information about the what each column represents so that we can better understand the data. Now I have provided the steps that I have followed in this project. These steps include first importing all the necessary Python libraries or modules. Second one is to load the dataset. Third one is to initialize instruction of dataset. Fourth one exploratory data analysis or data preprocessing. Fifth one is model building. Is model selection, seventh model interpretation, and model deployment. Here in the first section, I have imported libraries like NumPy, Pandas, Matplotlib, Seaborn, where NumPy is for numerical calculations, Panda is for data manipulation, Matplot and Seaborn are is for data visualization. Later, I have imported the machine learning models like uh, from the module sklearn, which is Scikit-learn. From the Scikit-learn, I have imported train test split, which the main purpose of train test split is to split our dataset into train data and test data. Other than that, I have imported standard scaler to scale our dataset and the models like linear regression, decision tree, K-maps, SVC, voting classifier, and tree. Here I haven't used voting classifier, and other than that, uh, I have imported evaluation matrices like confusion matrix, accuracy score, classification report to evaluate our model. Later, I have imported SMOTE to balance out our unbalanced data. I have imported joblib for model deployment and warnings to filter out all the unnecessary warnings. Before loading the dataset, I have made two assumptions that first of all, your uh, dataset is in a Google Colab because I have the because the file path is content slash load detections of CSV. Other than that, other than that, uh, keep this project and dataset in same folder and replace the path here with your dataset file path, and we can proceed further on. Here I have loaded our dataset, and after loading, first of all I have defined its save dimension so that we can better analyze how much space how much columns or rows are present in our dataset. Later, I have in detailed manner find out what are the columns of our dataset and what type of data type each column stores in our dataset. Here we can see that in 64, see, it means all the columns are are of int data type. Later, I have filtered out numerical columns and binary columns because in the above dataset we can see that only few columns are actual actual numerical columns. Other than that, other columns are are the binary columns or categorical columns which is converted into hard encoding through zeros and ones. Thus, I have filtered out the main numerical columns. Later, I have find out whether does it any column contain any null data type or not from gs.import. And now I have run my statistical analysis on numerical dataset like mean, median, mode, max, quantiles, 25 quantile, 50 quantile, etc. And now I have found whether there is any imbalancement in my dataset or not on my target variable. Here my target variable is loan status. So here I have seen that our loan status dataset is a heavily unbalanced data, as there are 36,000 datasets of 0 and one data and 4,640 datasets for 1. Later I have found whether any column is missing or whether any row is missing from this stage. I am performing basic exploratory data analysis. In the first data analysis portion, first of all, I have figure out whether there is any imbalance in our dataset or not. We are finding imbalance in dataset in only our target variable. Here our target variable is loan status. Thus I am finding any imbalancement in data column like loan status level. Here we can see that there is heavily imbalancement in our dataset is as there is very huge gap between these, and we can see it in that about 89% of dataset is about 0 and 11% is about 1. The next is I have found out whether any row is missing or not in our dataset for any column. Here I have found it that there is no missing data in data frame. I can already find out by this here. It is optional. And later I found out whether any row duplicated or not. If here we have seen that there are about 2,417 rows that is duplicated, and I have found see- uh, showing which rows are duplicated, and further I am removing those duplicates because the, here my dataset is very large and removing these duplicates will not affect our dataset. Here I have drawn the box plot to finding any anomaly or outliers in our dataset. Here the box plot is for all the entire columns. And separately I have drawn the box plot for only numerical datasets because uh, categorical datasets 0 and 1 there will be no anomaly in categorical datasets. Now the standard procedure to remove the outliers is IQR range where I have founded first quantile and third quantile and IQR. Here the lower bound and upper bound of each columns, numerical columns are provided below. Here we can see something like that. Age is 9.5 and campaign is minus 2.0. Normally age of applicant must be greater than 8 and campaign can't be in negative integer. So I later modified it. First of all, I have counted the uh, e- yeah, I have used standard procedure to remove the outliers. First of all, I counted Q1, first quantile, third quantile, and IQ range. The IQ range of all the numerical columns are given below, and later I have finded lower bound, upper bound, and here we can see something like that. The lower bound of campaign is negative number, and age is less than 18, which can't be possible. Other than that, I have figured out what are the outliers and what its distribution is like. Uh, in age, I have figured out how many are less than 18 years. In previous, I have found it what are the distribution of my data. And later, which I have discussed in lower bound, I have modified them to 18 and 0 and upper bound to 4 because most of the previous data set is about 4. So we can neglect the values like 5, 6, 7 as we are treating them as anomalies. Yeah. I have provided all the number of outliers in each data in each column. Here I have minorized all the outliers. We can also remove the outliers, but minorizing it maintain the maintain it from preventing any information loss. After removing outliers, I have verified whether the outlier is removed or not. As you can see in the box plot diagram, there is no outlier in age, campaign, and previous. These are not outliers as they as is significant. I have treated them as significant datasets, so haven't removed it. As you can see it here. Next is our data visualization part. In the data visualization part, I have visualized every numerical dataset into this diagram. Here we can see it. Later, I have shown bar graph of our main target variable. Later, I have done some feature engineering. Like here, we can see that about majority of our dataset is of pdays is 999. I have removed it and converted it as a hot encoding. Like 999 indicates that there is no here. The majority of our data is 999, which indicates no one has contacted him. So I have removed this dataset and converted into hot encoding. As and later I have seen for previous. Here I have hot encoded the pdays contacted dataset into zeros and ones. Later I have uh, find out the correlation matrix to figure out how much the numerical components are correlated to each other. The more correlated they are, the more their values will be towards +1 or -1. Here I have drawn some categorical features like job unknown, marcher unknown, because this data set, these columns are heavily balanced, like 5% or 3% of it. I have removed these columns like job column, marcher column, loan unknown, and hosting unknown. Later, I have after cleaning or preprocessing dataset, I am finding out the shape of my dataset and first 5 columns of my dataset. Later, I have separated my dataset into 2 parts: independent data and dependent data. Here, my dependent data is loan status, and the remaining columns are independent data. And we can see that first 5 columns of my independent data and first 5 columns of dependent data. Here, I have splitted my dataset into 3 categories: trained data, test data, validate data. Generally, we can split into datasets. Here I have uh, split it in 3 datasets: trained datasets for training our model, testing datasets for testing our model, and validating datasets for validate whether our model is correct or not and is performed as expected or not. I have uh, I have shown the shape of each dataset. That I have printed about 60% of my dataset is trained data, 20% of my data is test data, and the remaining 20% is my validated data. Now I have feature scaled my dataset because if some columns are very large in numbers, then they will more contribute to their dataset. They will more contribute to dependent dataset, which can make our model biased towards that feature. So I have scaled my datasets. I have scaled my datasets using scalar.fit transform, which first scales my data and transform it, and from same scaling I have scaled down my test data and validate data. After scaling my dataset, we can see the first five columns of train data, test data. Next part is, as we have seen above, that our dataset is heavily biased or heavily unbalanced. Here I have removed this unbalancement of data using SMOTE. Here SMOTE by synthetically uh, increasing or generating the minority data sets. As you can see that after generating minority data sets, they become balanced. In the model training section, I have taken some models like logistic regression, decision classifier, KNN, SVC, coding classifier. In the logistic regression, I have uh, classified put as balanced as to as to uh, as I have provided parameters like balance in our logistic regression so that it the model can perform better also for minority datasets so that it works both for both can work well for both minority and majority data. Similarly, in decision tree, I have provided parameter like balance in class weight and maximum weight 8 and minimum sample sleeve for preventing overfitting of my data. In KNN, I have provided njobs -1 and naive 10 and weight as distance, weight equal to distance for preventing weight equal to distance so that we can predict both majority and minority dataset perfectly. And later I have put these parameters value after hypertuning my Canon model. In the SBM model, since there are about 56 parameters, thus it becomes difficult for the model to handle. Thus, I have also used SBC. In the model prediction, I have predicted the train output on from the logistic regression. I have predicted our uh, target variable value for train data and test data. I have done similar procedure for decision tree, KNN, SVM. Later, I have evaluated our model using first of all through accuracy and then from confusion matrix, classification matrix, and below I have checked whether my data is overfitting or not. I have assumed that if about there is 15% difference in train or test accuracy, then my data set is overfitted by model. And for model visualization, I have used ROC AEC graph and precision recall graph so that I can find out threshold. I have used threshold parameter so that the model can perform also well for minority datasets. I have changing my dataset threshold value from using F4 graph, which we will see in later part. Here I have evaluated my model and we can see its classification reports, confusion matrix. Here I have for model evaluation results, I have drawn the RC curve. The more AUC towards one, the better it performs. Here I F1 score versus threshold graph is drawn. At the quicker value, our model works perfectly for both majority and minority datasets. From this value, I have find out which threshold should be picked. Later, I have drawn the confusion matrix report. And same I have done for decision tree. Similarly for KN model and SVM model. After uh, forming, after forming, training my models on trained data and evaluating the models on test data, I will find out some inferences like the accuracy of these models are given below, minority one and precision are below. Thus, I want that uh, my model can predict loan default, and in this section, I am selecting my model on the basis of what is their accuracy, precision for minority datasets, and recall for minority datasets. As in this model, I have considered that catching the loan defaulter is more crucial. Thus, I am choosing decision tree. And these are the reasons of my choosing decision tree, as for minority datasets has highest recall, and it perform well on a distribution for catching the risky cases of like finding defaults. After selecting my decision tree as best model, I have validate validating my model on validate datasets. Here I have I have chosen decision tree as my best model, and after choosing decision tree as best model, I have validated my model decision tree as my validate datasets and find out the decision tree accuracy, train accuracy. I have validated my model evaluation on validated datasets and find out later I have done model visualization, train accuracy, and evaluation, model evaluation, and from the choosing decision tree as best model, I have found later I have done model contributing features to the archival loan status applicable. We can see these features given below and their importance. As best model, I have found the top 10 contributing features. Later, I have also give a figure of how decision tree. We can see these filter out made data given below and their importances. And for model deployment, I have used joblib. Later, I have also give a figure of how decision tree. It can create a filter out made data set, which can later I use directly for our model deployment. I have model on other joblib.dump from which it can dot thank you period can create our dot pkl file which can later I use directly for our model on other datasets. Thank you. Thank you, Preprocessing, for giving me this opportunity on this project.